Hi everyone, welcome to our training of today, Modbus data logging of analog inputs. Today you can learn about how to log analog input data with Modbus data acquisition modules, example of analog input, our Modbus RTU remote I/O modules, and how to log the data using easy Datalogger software. ICPDAS was established in 1993. The headquarters is located in Hsinchu, Taiwan. ICPDAS USA was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers, and we work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, which means they are lab-free. Modbus is a data communication protocol originally published by DCON. It's called Schneider Electric in 1979 for use with their programmable logic controllers or PLC. Modbus has become a popular communication protocol and is now a commonly available means of connecting industrial electronic devices. Modbus is popular in the industry environment because it is openly published and royalty-free. It was developed by industrial application. It's relatively easy to deploy and maintain to other standards. The Modbus protocol uses character serial communication lines, Ethernet, or the Internet Protocol suite as a transport layer. Modbus RTU. This is used in serial communication and make use of a compact binary representation of the data for protocol communication. Modbus ASCII. This is used in serial communication and make use of ASCII characters for protocol communication. Another one is Modbus TCP. This is a Modbus variant used for communications over TCP IP networks. You can connect it to Modbus TCP over port 502. Modbus object types are provided by a Modbus slave device to a Modbus master device. All data is stored in registers of these types, including coil, discrete input, input register, and holding register. Due to the size limit, coil and discrete input can only store digital output or input data. For input register and holding register can store analog input or output data because they can have 16 bits of size. Analog signal is one whose value continuously varies over time. For example, analog inputs for PLC can include signals from pressure transducer and temperature from thermocouples. A common example of standard analog I/O are 4 to 20 milliamps for current, and ranging from 0 to 120 volt AC or 0 to 48 volt DC for voltage. By contrast, a digital or discrete signal is one with a value at a specific interval of time. Think of a switch or relay, a motor, or an indicator light. They can only have two states, either on or off. M7000 series data acquisition remote I/O module support Modbus RTU and DCON protocol. They come in a wide variety of analog and digital configurations. The analog and digital I/O types they support include current, voltage, thermistor, thermocouples, LTD, frequency, relay, strain gauge, etc. This table shows some of our analog input modules for Modbus RTU protocol. The M7017 is an 8-channel voltage and current input modules. This is a family of network data acquisition and control module that supports Modbus RTU. It can be remotely controlled using a set of commands called DCON protocol. With the Modbus RTU protocol, it can easily communicate with most popular SCADA, HMI software, and PLCs. Datalogger is a free computer-based data logging, data acquisition, control, and monitor software. You can log data from our data acquisition hardware like M7000 modules or ET7000 modules. Data is stored in a database in computer, or it can be exported to or uploaded to any SQL database. Datalogger is designed for small remote I/O systems with up to 64 I/O tags for the free version. You need at least one ICPDAS module to use Datalogger. Advanced version of Datalogger is also available and is our easy-to-use data logging software for advanced application. It supports up to 1024 I/O tags, 10 SMS or email alarm contacts, and up to 10 web cameras. Now I will pass it to Robert, which is our application engineer, to show you how to log data using Datalogger software.
Okay, for the hands-on demonstration, we will show you how to connect a Modbus RTU slave device to our Datalogger software. This particular module has analog inputs, so we will show you how to connect the analog inputs and how to scale the analog input values. The topics we will cover during this portion are what you need to log Modbus data in Datalogger, how to add one of our ICPDAS Modbus RTU data acquisition modules, and how to scale the Modbus analog data to display the correct value that corresponds with your analog input that you want to display. First of all, what you need. You will need a power supply to power your analog input module. In this case, we're using our M7017 module for our data acquisition module. You need a Modbus register table, which we publish in our manuals and also in our Modbus register table manual. You need to know the communication settings, specifically the baud rate parity and Modbus ID. These can be done in our DCON utility when configuring the module, or out of the box, the default values are Modbus ID 1, baud rate 9600, and parity option none 81. You also need an RS485 converter if you do not have one. For this example, we're going to be using our TM7561 USB to RS485 converter. This is an example of a Modbus register table from our manual. We will be using the M7017 module. We will be concentrating on the 30001 through 30008 analog input registers, channels 0 through 7. These are read-only, and I have provided a link above to this particular manual. The wiring diagram for this module, or this setup, we will be connecting our USB cable to our TM7561, which is a USB to RS485 converter. It is recognized as COM port 7 on my PC, but it may be different on your PC. Then you connect the 2-wire RS-485 to the data plus and data minus of the M7017. And finally, you connect your power supply to power the M7017 module. Along with this, you want to connect your sensors to one of the 8 inputs labeled channel 0 through 7. And to complete the data logging steps, you configure the module using DCON utility. In the top left, I show an example of the configuration we'll be using. This module is configured in Modbus RTU format, address 1, baud rate 9600. Data format is set in engineering format, and the input range for all channels is plus or minus 10 volts DC. On the top right corner, you can see a sample of the data. I do have a 6-volt DC signal going to channel 0, and I'm not really going to use any of the other ones. Later on during the example, I will connect something to channel 4 to display some scaling values. Here's a link to download the Easy Datalogger software, the latest version. It's downloadable from this link and available on our website. Once you install the Easy Datalogger software, the first time it's required to run as administrator. This way, Easy Datalogger can install all OCX files that are required to run the software. Once Easy Datalogger is installed and all the OCX files are updated, Easy Datalogger can be opened without administrator rights. So you can just open it normally by double-clicking. But again, the first time you must run as administrator by right-clicking and select Run as Administrator in most cases. Now we'll get on to the Easy Datalogger demo. I will show you how to connect an M7017 module to our Easy Datalogger. The first step is to get the software here. I guess we'll expand it this way. Okay, let's see. First thing you want to do is get to the home screen here. Okay, you want to create a new project. So for this project, we'll call it, oops, let me drag this over, M7017 demo. Drag it back over here. Okay, so from here, the first step is to go to Group Setup. And let's see. Okay, from here, you first want to install your connection or create your connection to Easy Datalogger, or I'm sorry, through Easy Datalogger to the M7017 module. First, you click Install. This window will pop up. From here, you want to select Modbus Serial, which is the same as Modbus RTU. The COM port that we're connected from the previous slide is COM port 7. So I select COM port 7. The baud rate from the previous screen is 9600. Data bits 8, parity none, stop bits 1. Everything else we'll leave as default for this demonstration. Then you click on Install, and notice that up here, Modbus Serial with COM7 connection appears up here. Then we click on Plus Device. This will pop up this window right here, which note COM7 shows up here with your connection. Then, because you're using one of our data acquisition modules, you can use the drop-down list to cheat. This, by selecting the corresponding module, you can automatically configure the properties. If you don't know the properties or want to just adjust them, you can certainly adjust these numbers by typing it or checking the boxes with the corresponding data types. For instance, if you wanted to monitor additional channels like counter channels or something for modules where it's not pre-configured here, you can certainly do that by just adding a second connection or adding a second set of registers. So from here, we click on the word add, and this will pop up the M7017 module here. We can close this window here, and we can close the connection to the driver. So notice that we have Modbus serial COM7 up here. This shows the connection to the module, and then we add the device. In this case, M7017 module. If we had additional modules connected in daisy chain to the same COM port, we can either select add or configure from the previous screen. Because this is an analog input channel, this AI list is populated with these 8 channels, channels 0 through 7, when I added the M7017 module. From here, you want to select the modules that you want to, or I'm sorry, the analog channels that you want to log by highlighting them and clicking add. They will appear over here with a plus sign next to it. And you can also create different work groups to log different groups of analog inputs or different combinations of channel. If we wanted to scale the values, let's see, I'll show you that shortly. Let me just do this first. So first we want to verify our connection and our analog inputs are read properly. So I will click on the home button, and that brings us to the home screen. Drag it back over here. Okay, this is the home screen. So from here we want to click on the start button. Notice right here in the top left corner, this box is shown as red. This will show the communication status for the M7017 module. So once I click start, if everything was configured properly, we should see a green box instead of a red box. It did turn green, so we're good. And then we can click on the trend curve and see the analog input. Oops. Values shown here. Let's see. Oh, okay. Because of the scaling values, we need to adjust the axis. Let's see. So I will make it 7,000 just so that you can see the whole thing. So if we isolate channel 0, which is the main channel which I have something connected, by unchecking the rest, we can see that it's a steady 6.194 volts. This needs to be scaled because of the Modbus value. Modbus has no decimal points. That's one reason we need to scale. So what we'll do next is show you how to scale the value so that you will be able to read the actual value or an adjusted value based on what you want to display. Let's see, so we need to stop the data logging to do this. We want to go back to the group setup. And let me drag the screen back over. Let's maximize it. Okay, so from here, in our AI list, we simply double-click on the channel, and it brings up a properties window for that specific channel. From this window, we could rename the value, like for instance, if we wanted to call it temperature. Let's see, let's call it temperature. And say we need, well, let's see, for this example, we need to scale it by a factor 1,000. So what we could do here is there's 2 ways to do it. You can either program in a gain and an offset, which is like y equals mx plus b, where the multiplier is the gain and the offset would be the b. So if we were doing temperature, the formula would be y, or degrees Fahrenheit, equals 9/5 plus 32. So this would be equal to 9/5. Since we need to put it in decimal, it would be 1.8. And for this value, it'd just be the 32. Another way you could do it is use the AI display value and the actual AI value to calculate. So for instance, in this case, let's just ignore these for now. Since our analog input value is multiplied by a factor of 1,000, we can do it simply this way. 1,000 equals 1 and 10,000 equals 10, and we just click calculate. And what it does is it calculates the gain and offset value. Since all we're doing is dividing by 1,000 in this case, this is the result. And from here we click on modify to save the results. And we can click on home to return to the screen to get to our workgroup settings. Drag it back over here, and we click start. Should see a green light here, and then we click back on our trend curve. And we should see our value of 6.194. We need to check this, and we need to get the axes back to, let's do 100, and we can see our value here. Let's go back to the PowerPoint. Oops. Okay. Here's a little bit more information concerning that. So prior to scaling, we can find the actual value that the data acquisition module puts out using a section in our manual. We are using type code 8, which is the -10 to 10 volt range. And in the manual, it shows that the value is between -10,000 and +10,000. So it's multiplied by a factor of 1,000. The scaling is done using these values here, either the gain and offset, where we can multiply by 1/1000th, or we can use the dual point method to just calculate the value using 2 known points. A little bit more information about that. Here's an example of the 2 methods. Again, the first method is the y equals mxb or mx plus b method, where you m is equal to the gain, which is the multiplier, and b is the offset. It's a offset number. So in this case, if we did temperature, it'd be 32, as shown on the far right side. Also with the 2-point method, if you have 2 known values at 2 different points, for temperature I'd use like 0 equals 32 degrees, 0 degrees Celsius equals 32 degrees Fahrenheit, and 100 degrees Celsius equals 212 degrees Fahrenheit. And you could also calculate the same values. So either in the scale and offset, you put in 9/5, and in this case we'd put 3200 because of the offset, or if it was 3 digits, to be 32,000. For our temperatures, though, I believe it's 3200. For the 2-point method, we can do similar thing by using 2 AI values and the display values, and you clicking the word calculate. Let's see if you have any questions about this presentation, or have any questions about Easy Datalogger or any of our products. Our contact information is shown here. And there are additional videos shown at our YouTube channel with the link at the bottom of the screen.